So thanks for coming. I think I will start. So in the next 20 to 25 minutes, I will try to show you why we at Durst think that large format has to become water-based, or at least more water-based than it is up to now. And that we can, by doing this, combine sustainability topics like health and environmental friendliness with highest print qualities, as you see here, and with industrial production scales and reliability. So, the Durst water technology. So our long-term strategy is that we develop non-toxic, odorless, and migration-free printer systems, which have high productivities, as we know this, for example, from digital UV inkjet printing. Why we do this, I will tell you in the next slides. The first milestone in this area was the introduction of our Rotex water-based printers. They are printers for dispersed dye inks. We introduced this 2010. This technology guarantees good image qualities and a clean and sustainable production process. And for the industrial scale, we can print up to 900 square meters per hour. So this was the first series we introduced in this large format area of water-based. So let's go back and check the inkjet technology involvement in the last 30 years. So it started all with solvent inks, in the 90s. Then the UV inks came up 2000 something. And now at Durst we started with the water-based inks with the Rotex, but also for other textiles, as you see here all around, we have water-based inks. So the question is now, do we need more water? Why do we need more water? So there are several issues with solvent inks and UV inks. And this is that we have new classification of chemicals coming from REACH, or that some raw material producer finds out that it's not as harmless as he thought before. We have the other issue with the UV inks. We have the migration issue, so we cannot go to food packaging so easily. And we have all this emission and health issue when you think on VOC, etc. So all these restrictions here, they limit us for going to new applications like interior design and packaging. So we want to get rid of all this order, the migration, and of all these labels here. And then we hope that we have a good starting point for these new areas here. And of course we want to play a major role here. So again, back to our textile very shortly. So this is what is already done since 2010 with our Rotex machines. So we print there with sublimation dye inks on polyester sheets, and we can have banners, posters, POP, POS displays, indoor graphic, trade show displays, and so on. An advantage here is that we have an ink system of water, some glycol, and some harmless dispersed dye. And this guarantees us a clean and sustainable production technology. This is environmentally friendly because these are very eco-friendly water-based inks. We are odorless, the dyes are skin-friendly, and we are free of VOCs. And this is certified by all these labels here. Okay, so next generation. So this was our new development aim here. Is can we create a flatbed printer generation for rigid materials? So with the soft signage area, we have the flexible polyester media, and now here we want to introduce it for rigid, like corrugated PVC sheets and so on. Before we were thinking, okay, what quality criteria do we need? So first of all, we thought, can we become better than UV? So can we reach something like litho quality, so that we don't have the structured feeling anymore, maybe we have a better brilliance of the colors, we have a higher gloss, and so on. We wanted to address this to common flatbed media because there is not such a printer existing yet. We don't want to get rid of the other so that we can go to indoor applications, and we want to have it ready for low migration applications. And this, because we are Durst, we wanted to combine this with highest printer productivities. So we want to print 24 hours a day. We want to have highest production speeds, so in the range of several hundred square meters per hour. There has to be low maintenance efforts, and we need competitive running costs, of course. So then we figured out that we have a very close look to these three key technologies. So we have we have to take care about the ink. So this has to adhere at the substrate, it has to produce durable films and so on, resistant films. We have to adapt our drying and curing technology to this kind of inks. Or we need a printhead technology which allows us good reliability and very, very low maintenance efforts. All right, let's start with the ink. We checked several ink prototype systems which are available on the market, and we came up finally with this type of ink. So this is composed basically of UV reactive molecules which are solved in water. So we have some oligomers, we have photoinitiator, of course the pigments, and this is solved in water. So we have still on the positive side for the UV, we have the high adhesion range to several substrates. We have good resistance parameters, so when it goes to scratch resistance, water resistance, and so on, and we can achieve good durabilities. So up till now, we say we have 2 years for indoor applications. By solving these molecules in the water, we can use harmless molecules than in the conventional UV systems, and this assures us odor-free films, which are of high flexibility because the ink film is thinner, so it's not 100% anymore, but we evaporate the water and therefore it's thinner, and the films do not crack up so easily. And because it's label-free, so these molecules are less harmless than before, we hope that we have a good starting point for low migration applications. And because we have the best of these two worlds, so the function that it stays on the substrate with the UV molecules, and the environmentally and sustainable aspect from the water, we call this our functional aqueous ink. Okay, so that's the drying and curing technology. This is the status of our FESPA model we show here at FESPA. So the ink is printed with a print carriage where all the printheads are assembled. It is pinned with IR. So pinning works like that we remove some of the solvent with thermal energy. The viscosity goes up, the drop stays there, and we don't have intercolor bleeding and such things. Then we have a second stage, which is a thermal dryer again. This removes all the rest of the water. And finally, there comes a final UV curing of low dose. We have to admit that we cannot run full speed here at FESPA, so we are still working at this dryer thing here. Our engineers are working at that. So we want to reduce this and that we can print as fast as we want. Good, so let's come to the printhead. This is the printhead technology which is inside this machine, and this is inspired from our ceramics printhead technology, the gamma technology. So what we have here is that we have here directly behind the nozzle plate we have ink circulation. So the ink is always moving. And this allows very high open times and very good reliabilities. What comes in addition is that we have a non-wetting coating on the nozzle plate, so this prevents ink buildup there and drying of ink on the nozzle plate, and so you do not have to wipe so often than when this wouldn't be there. So the maintenance up to now is that we need one wet cleaning in the morning and one purge per working shift. So that's in principle the model which is on the FESPA. Without when you check this machine at our booth, there is in plus the curing unit. So it's a little bit bigger than here. But you see, it's in principle looking like our flatbed UV printers, but we changed a lot there. So all the tanks, the filling, the tubings and so, they were changed that they are compatible with water-based inks, so that we don't have corrosion and such things. All this high-tech, this print carriage was changed with the other printheads. We changed the lamps and adjusted everything, and that's how it looks like. How it's looking like now at the FESPA. Well, these are the technical key features. We implemented the circulating Durst quadra-array 10WM printheads. They generate drop sizes of 10 picoliter. We have resolutions up to 1000 dpi. We use thermal pinning and drying in combination with conventional UV curing at the end. We print up to 6 colors. And we want to reach productivities up to 400 square meters per hour with this machine. We have to admit that we are still in optimization stage with the pitting and curing. That's also the reason why you cannot buy it here at our booth. So, the media we can address. So this is an overview of the most important rigid media for large format printing made by our Market Research Institute. And you see here the most important is rigid PVC, and then comes the paperboard and so on. And with this machine and the ink type, so the functional aqueous ink, we can cover most of the rigid PVC material. The paperboard we can deal with, not the acrylic, so it doesn't adhere yet to the acrylic. This is a work in progress. We can deal with corrugated. Polycarbonate metals are also not yet available, and some others also not. But as you see, as the PVC is the most important, at least in Europe, we can up to now deal with 50% of all the important rigid materials, and we will improve this in the future to also deal with the rest of them. So until now, UV is not made obsolete, but this is a good addition to UV printing for rigid media. So in summary, I hope that I could show you that our Durst functional aqueous technology combines new print quality criteria, also in terms of sustainability, so health issues, environmental friendliness, with highest total cost of ownership criteria. So we have highest image quality. We could improve the gloss, and there is no structured feeling anymore. Then with conventional UV, you can check this here or at our booth. Then it's completely odorless, so you can also check this or better at our booth, and you see the machine running. It is ready for low migration applications. We can already cover a broad media range, including non-absorbent materials. We reach highest productivities, up to several hundred square meters per hour, and we need just low maintenance. Okay, that's it. Thank you for your attention, and please visit us at Hall 7K10.